Hey everyone, it's Spencer from 421. I'm one of the Ceph experts over at 421, and a lot of my typical roles involve things like Ceph architecture, cluster design, uh, planning and projecting for cluster growths and upgrades and things like that. So a lot of architecture work, and of course, the more emergency assistance and standard consultation as well. But for the most part, I like architecture design. So with that being said, the next couple videos I'm going to do are going to be about that kind of Ceph architecture concepts within Ceph, how to design clusters, how to build clusters, core concepts. So to get started, we're going to be covering a fairly basic Ceph concept of just what a pool is. So you can see I have this little agenda here for us. So covering what a pool is, kind of the pool structures, properties of pools, so what we assign to pools when we create them, erasure coding versus replica, so the two main ways that data can be written in Ceph, and then just common challenges that people have with pools. To get started, I'll move our little agenda away and get some scratch space here. What is a pool? So a pool in Ceph is a logical unit of storage that interfaces with a user. So a pool is the top level logical unit where user access is actually done. So if we have a pool up here, this is where all of our users will actually ingress into the cluster. Pools are then made up of multiple smaller units. So PGs is the first unit. You'll have a number of PGs in a given pool. PG also means placement group. Those placement groups then break down into individual OSDs. So this could be hard drives, HDDs, or it could be SSDs or NVMEs. Any number of devices could be there. But really, this is just the logical flow of data in Ceph. So when a write comes in, it hits the pool moves that to a given PG. A given PG then assigns that out to the OSDs that are under its control. Ceph does this mechanism to allow it to scale better. So having these logical units that are cut up into smaller segments as it goes down helps with like indexing and scanning. That's how Ceph manages a lot of its scalability. But that's the kind of core concept of what a pool is. Some properties of the pool, though. You have a couple properties. The first one is going to be the application or the app. The application could be CephFS or filesystem, RBD, which is the block storage protocol, or RGW, which is for object storage, S3 or Swift. So that's the actual application, the end application that's going to be using the pool. You then have your redundancy profile or your redundancy. This is going to be the level at which data is stored. So it could be OSD level. So it's just stored across any select OSDs. It could be on host so that it stores data across multiple servers. Could even be rack if you had rack units, or even higher, like data centers or whatever other arbitrary unit you'd have. Then you would have its data placement method. So that would be EC or replica, which we'll cover in a second. And then, of course, you'd have the PG number. So the number of PGs assigned to the pool. So those are your core properties of a Ceph pool. So when we design a Ceph pool and we're actually building one out, we first pick an application. So let's say I'm going to be using an RBD pool. So RBD is going to be my application. My redundancy, so that's going to be OSD, host level, rack level, whatever. That's going to determine how many units or of what type of unit can fail before this cluster gets in trouble, this pool gets in trouble. So typically that's going to be at host level. So multiple servers involved, host level. Then we got to pick between erasure coding or replica. So those are the two data placement methods within Ceph. Replica is copies. So you're literally just taking direct copies of a given object and splitting them across the cluster. So if you write once, you're actually writing 3 copies, for example. Erasure coding is a bit more complicated. It's more like a RAID setup. So you have parity chunks and data chunks. So every time you write an object, it's cut into a certain number of data chunks, then a certain number of parity chunks as well. there's different reasons to use those different profiles. We'll get into them in more detail as we kind of go through this series here. But we'll go with replica for this. Replica often tends to perform better for like random applications, assuming our RBD is going to be backing something like a OpenStack environment. So for hosting VMs, for example, that's going to be a bit more of a random operation. So replica is going to be better for that overall. So now that we have these two, we also need to determine how redundant this is. So I have, it is redundant at host level and it uses replica. I now need to define the number of replicas that I'm going to use. In my case, it's going to be 3, which is also the default. So we have a 3 rep pool. That means every object is actually written 3 times. You can change that up as you kind of want more redundancy if data is more important. You generally don't want to lower it below 3 though. 3 is the default and it's default for a reason. And then we have to pick our pgnum. Pgnum is a function of the available PGs in a cluster. So every PG has kind of a finite number, every cluster has a finite number of PGs based on the total number of devices in the cluster. So let's say I had 10 SSDs in this pool. I'm pretty comfortable putting around 200 PGs up to maybe 300 per OSD if they're backed by SSD. So that would be 2000 PGs available here. So this pgnum has to be a function of my total PG budget. Typically, the way you would balance that is based off used capacity. So if you had like 2 pools and they're both going to be used about 50% of the time, you'd assign 50% of your PGs to pool 1, 50% of your PGs to pool 2, so that they're evenly distributed. In my case, I'm just going to give this pool, say, 128. So 128 PGs. Now, how this pool actually plays out, we have our pool up top. It's a RBD pool. That is 3 rep with 128 PGs. So that means the application is RBD, and there are 128 of these smaller PG units here. I'm not going to draw out 128 of these, of course, but that keeps going. Under each PG, since we're a 3 replica cluster, there needs to be 3 OSDs. Since we also defined that this is a host level 3 replica pool, that means each of these OSDs must be on a physically separate host. So that means we could lose multiple of these hosts before we get into any real trouble. So when a user uses this pool and writes to their RBD, so let's say you give them an image, they host their VM off of the image. When a write comes through, the write goes to the pool gives it to a PG, the PG writes to what it calls the primary OSD, then the primary OSD handles the replication to the secondary and the tertiary OSDs. Once that operation is completed, Ceph will acknowledge this write as being completed. So just to note that these writes are not completed until all of the replicas are finished. So once we have that, our write is complete, and that's kind of the overview of how our pool influences our write pattern. Now, some common challenges that people run into with pools. Firstly, PG balance. PG balance. So what I mean by this is, like I talked about earlier, you have a fixed budget of PGs available in a given cluster, and you need to assign those to your given pools. So a lot of the times people will make a bunch of different pools just to try to like segregate user access. So they'll have like RBD pool 1, RBD 1, RBD pool 2, and so on and so forth. And that becomes really challenging really quickly because you have a finite number of PGs and you keep adding more pools. So that means each new pool you make has less PGs. So maybe this guy only has 32 now and this one had 128 because you're out of budget. That's why keeping in mind that pools are application level, so pools equal application, is really important, because instead of having multiple RBD pools for our arbitrary kind of user separation, we really should just have one big RBD pool, because the RBD is the application. So pools equal applications. This RBD pool, we can then segregate users based off of authentication or Rados namespaces. There's a number of ways to do user separation within this pool, but giving it a single pool means we can assign all of our PGs to this single pool, get a lot more performance out of it, rather than having multiple pools with kind of different PG values, which quickly can run into some performance problems. The other common challenge that people run into with pools is just projecting data usage. So an important thing to keep in mind is that pools are logical. What I mean by that is they're a logical unit. They're not actually a defined resource necessarily. So if I had, going back to my example of 10 SSDs, that amount of storage is available to my entire cluster. If I then make multiple pools, so an RBD pool and an RGW pool, and let's say they're both 3 replica, they're pulling from the same common storage there. So they're both pulling from the 10 SSDs I have. That means if, let's say, there was 600 terabytes available of storage across those 10 OSDs, both of these pools report 600 terabytes. The problem there becomes if you write to the RBD pool here, it's going to take available storage away from, of course, itself, but also the RGW pool, because they're pulling from the same common resource. So maybe it goes down to like 550 each. So a lot of the times people will track data usage globally without keeping in mind that their pools are pulling from the same common resource. So you actually need to keep in mind that these don't actually have the 500 and something terabytes available that they're reporting. That's the available for the cluster or whatever unit, storage unit you've defined. So SSDs, NVMEs, hard drives, so on and so forth. It is not the actual true pool's availability, because it can change based on other pools' usage. So it's just something to keep in mind. Those are kind of the two main challenges that I see anyways that people run into. Other than that, pools are a pretty straightforward concept. I think next time we're going to start talking about kind of more on the replica and erasure coding front, the differences between them, where I would and wouldn't use them, and also how I would design those profiles. So I talked about, 3 replica, and I wouldn't go below 3 replica. So next video, we're going to talk about why I wouldn't go below 3 replica, what type of erasure coding profiles I would use, and for which specific use cases and applications. But for now, that's pretty much it. If there's any questions, feel free to reach out. I'd be happy to help anything and clarify any of the information that's been in this video. Otherwise, I will see you all next time.